Hello students, welcome back to my channel. Today we will discuss something about optics, which covers 1/3 of your second unit for +2 students. +2 is concerned, 1/3 of your second volume is entirely covers optics. So I will give you brief introduction to optics, some terminologies which are closely related to optics so that you can easily understand the concepts within the optics chapter, right? So optics is study of light. Optics means study of light. So light, when we are discussing about light, you must know some characteristics about light. So what is light? What are its properties or characteristics? So characteristics are concerned, let me give you point by point. Light is a form of energy. Light is one form of energy. Light travels in a straight line. Light travels in a straight line. We call it as rectilinear propagation. Rectilinear propagation of light. Now, the velocity or speed with which light travels is 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter second with which the velocity of light moving in vacuum. In medium, its speed or velocity differs, right? Now, this 3 into 10 power 8 meter per second is equivalent to 3 lakhs kilometer. How many kilometers? 3 lakhs kilometer per second. Just imagine the speed of light. So this we are going to use in optical fiber communication. If you say hello in one end of your phone, the person who is in America can get your voice within no second. That is because of the velocity of light. Now, light undergoes different phenomena like reflection, refraction, interference, diffraction, and polarization. So these are all the phenomena we are going to study deep when we go into that particular chapter. I will give the definition, simple definition. What is reflection, what is refraction, what is interference, what is diffraction, and what is polarization. When we move on to that particular chapter, we will discuss elaborately. Right. Light is again a part of electromagnetic spectrum. Light is a part of electromagnetic spectrum. Electromagnetic spectrum starting from radio waves, which is having longer wavelength, and ends in gamma rays, shorter wavelength. Based on the wavelength and frequency, you can classify electromagnetic spectrum into 7-8 parts. Radio waves, microwaves, infrared, visible spectrum, ultraviolet, X-rays and gamma rays. Like that you can split it. So visible light is part of electromagnetic spectrum. Right. For the propagation of these light, no material medium is required. That is, it does not require any material medium for its propagation. That is, it can travel even in vacuum. Now, light behaves as particle and as waves. In some energy regions, it acts like a particle, and some other energy regions, it behaves like a wave. Interference, the phenomena like interference, diffraction, and polarization is possible only when light is behaving like a waves. And some phenomena like photoelectric effect and Compton effect, we are going to discuss in detail in the forthcoming chapters. In those phenomena, light is purely treated as particle. Unless otherwise it is treated as particle, those phenomena are not at all possible. Similarly, for interference, diffraction, and polarization, unless otherwise light is treated as a wave, these phenomena are not possible. Clear now? So behaves as a particle and wave. So it is having dual nature. That we'll discuss in detail in forthcoming chapters. Right. Energy carried by a light photon. So light is carrying some energy. That energy is equal to, if it is a particle, E equal to mc square. where m is mass of the particle, c is velocity of light. If it is a wave, E equal to h nu. Nu is frequency, h is Planck's constant, whose value is 6.625 into 10 power minus 34 joule second. Unit of Planck's constant is joule second, whose value is 6.625 into 10 power minus 34 joule seconds. So these are all important questions. Same questions may be asked in your board. What is the unit of joule constant? Or sorry, Planck's constant. What is the unit of Planck's constant? So unit of Planck's constant is joule second. Then light waves are transverse in nature. Light waves are transverse in nature. What is transverse? You have come across in your earlier classes. Transverse wave is alternate crest and troughs are formed. The distance between two consecutive crests is wavelength. That means the vibration of the particles at right angles to the direction of motion of the wave. Vibration of the particles are at right angles to the direction of propagation of the wave. Those waves are, we call it as transverse wave. So here light waves are transverse in nature. While discussing about sound, we will discuss in detail these transverse wave and longitudinal waves elaborately. Now, coming to the relation connecting velocity, frequency and wavelength. So these are all the terminologies very frequently are going to use in this particular chapter. C equal to nu lambda. C equal to nu lambda. Here C is velocity of light or velocity. Nu is frequency. Nu is frequency. So what is frequency? Frequency is number of vibrations produced by a wave in 1 second. Number of vibrations per second for a vibrating body. Number of oscillations per second for a oscillating body. Number of rotations per second for a rotating body. So nu refers to, the symbol here is nu. Frequency, nu refers to frequency, and lambda is wavelength. Lambda is wavelength. The distance between two consecutive crests or two consecutive troughs, or distance traveled by a particle, vibrating particle, to complete one cycle. To complete one cycle. This also we name it as lambda, wavelength. The relation connecting velocity, frequency and wavelength is C equal to nu lambda. Very often we are going to use in this particular chapter. So keep it in your mind. And again we are coming to another terminology, which is refractive index. Refractive index, symbolically it is mu, MEW, pronounce it as mu, or in some books you may find it as N. The symbol for refractive index is N. You can write mu equal to C by V or N equal to C by V. Here C refers to velocity of light in vacuum or air. C is velocity of light in vacuum, and V is velocity of light in the medium. So you can define refractive index as the ratio between velocity of light in vacuum and velocity of light in the medium. One of the definitions for refractive index. Now, the law governs reflection and refraction. I am just going to give you something on reflection. What are two laws of reflection? So first law states that suppose this is a mirror. Draw normal to the mirror. Now let a ray incident on this mirror in this angle. Let I be the angle of incidence, and it gets reflected through an angle which is R. The first law states that the angle of incidence, that means angle subtended by the incident ray with the normal, is angle of incidence, is equal to the angle of reflection. Angle of incidence is equal to angle of reflection. Angle of reflection is the angle subtended by the reflected ray with the normal. So this is one law, which is laws of reflection. And the second law is the incident ray and the reflected ray and normal. All these three lies in a single plane. Incident ray, reflected ray and normal. All the three lies in a single plane. So these two are termed as laws of reflection. Now I will come for laws of refraction. Laws of refraction is concerned. One of the laws is similar to a law of reflection. The incident ray, here law of refraction requires two media. Say for example, this is incident ray. I draw a normal to this. This is medium 1. This is medium 2. So say for example, this is glass. This is glass medium. Now, whenever a light ray encounters a second medium, that means a ray passing from one medium to another medium, no longer it passes straightly, but it gets deviated. It gets refraction. This phenomenon is called refraction. Through some angle, here this angle R is angle of refraction. Don't get confused with reflection and refraction. Refraction requires two media. Keep it in your mind, two media. Angle of incidence is I, angle of refraction in the second medium is R. That is angle subtended by the refracted ray within the medium with the normal is angle of refraction. The incident ray, the normal and the refracted ray, all the three lies in a single plane. That is one law on refraction. Another famous law is law of refraction is Snell's law. Snell's law states that whenever a light passing from one medium to another medium, the ratio sine of angle of incidence and sine of angle of refraction is always equal to a constant. That constant is known as refractive index of the second medium. Refractive index of the second medium we call it as mu2 1 or mu2 by mu1. So simply mu is sin I by sin R, where mu is refractive index of the second medium equal to the ratio of sine of the angle of incidence and the sine of angle of refraction. This famous law is devised by Snell. This is Snell's law. So another two definitions for refractive index in terms of actual depth and apparent depth. Actual depth and apparent depth, let me give you small illustration. So in a beaker, you have taken some water, you drop one pen or one coin. Now, coin appears to be raised a little up while viewing from the outside. The coin appears to be little bit raised from the bottom. So now the actual depth is let be h, and this is apparent depth be h dash. Now h by h dash gives you the refractive index of the medium. Here it is water. So refractive index of the water can be measured in terms of the depth. Actual depth is h, which is at the bottom. You are measuring from the bottom, and the apparent depth is when you view through outside, the coin appears to be little up. So there is some difference between bottom and the apparent height. So ratio between actual depth and the apparent depth, another way of defining refractive index of the medium. As far as liquids are concerned, you are going to find the refractive index like this only. So mu, refractive index, is actual depth by apparent depth. Okay, just listen to me. whenever a light travels from one medium to another medium, its frequency does not changes, but velocity and wavelength changes accordingly. Velocity and wavelength undergoes changes, but frequency remains as such constant. No change in frequency. That is one very important question as far as board or competitive examinations are concerned. So whenever a light ray entering from one medium to another medium, whether it's rarer to denser or denser to rarer, irrespective of the nature of the medium, whether it goes from rarer to denser or denser to rarer, its frequency remains unchanged, but wavelength changes accordingly, velocity also changes. Now let lambda 1 be the wavelength of light when it is passing through vacuum. So we know the relation already, C equal to nu lambda 1. Then let lambda 2 be the wavelength of the same light when it is in the medium, when it is passing through the medium. So velocity of light in the medium, I am representing it as V. Velocity of light in vacuum is C. Velocity of light in the medium, I am representing as V. So V equal to nu into lambda 2. Now we know refractive index mu equal to C by V. Now C is nu lambda 1 by nu lambda 2. So simply nu gets cancelled, lambda 1 by lambda 2, which is equal to mu. So refractive index can also be defined as the ratio of wavelength of light in first medium and second medium, or vacuum and medium if it is from vacuum, or one medium to another medium, means the ratio between the wavelength of the first medium and the wavelength of second medium. This ratio gives again refractive index. So totally 4 different ways you can define refractive index. One main question, one part 1 or part B, or even competitive examination, from refractive index phenomenon you are going to get one question. Clear? So in terms of velocity of light, it is the ratio between velocity of light in vacuum by velocity of light in the medium, that is C by V. In terms of angle of incidence and angle of refraction, Snell's law, mu equal to sin I by sin R. In terms of depth, it is the ratio between actual depth and apparent depth, that I explained already. In terms of wavelength, it is the ratio between wavelength of the light in first medium and wavelength of light in the second medium. This ratio gives again refractive index. Okay, with this let me conclude this session. From next video will be detailing each and every topic comprising in your optics chapter. Goodbye.